Hello everyone, welcome to IITJEE Mathematics Adda. So today we are going to discuss some problems from trigonometric equation from Bansal material. Okay, so this is 1 plus sin cube x plus cos cube x equals to 3 by 2 into sin 2x. We have to find general solution of x. Okay, so here what is a cube plus b cube formula? Okay, that is a plus b into a square minus ab plus b square. So there sin cube x plus cos cube x is given, so I will use this formula only, that is 1 plus sin x plus cos x into sin square x minus sin x cos x plus cos square x equals to 3 by 2 into what is sin 2x? 2 sin x into cos x. Okay, now this 2 and this 2 will get cancelled and sin square x plus cos square x will be equals to 1. Okay, so just see this, that is 1 plus sin x plus cos x into 1 minus sin x cos x, that equals to 3 sin x cos x. Okay, this type of problems, whenever addition of sin cos and product is given, we have to assume sin x plus cos x is equals to some variable. Okay, let's say y. Okay, now square on both sides, that is 1 plus a square plus b square, it is 1. Okay, 2 sin x cos x, when I am squaring on both sides, so that is y square. Okay, so what is sin x cos x? Because in the above equation we have to put sin x cos x only, that is y square minus 1 by 2. So substitute these values in the above equation. Okay, so that is 1 plus y into 1 minus y square minus 1 by 2 is equals to, okay, 3 by 2 into y square minus 1. Fine. So now try to simplify this one. 1 plus, I am multiplying inside y, that is y minus of y cube minus y by 2 is equals to 3y square minus 3 by 2. Okay, so LHS side also I will take 2 LCM, so that is 2 plus 2y minus y cube plus y, okay, by 2, which is equals to 3y square minus 3 by 2. So 2 will get cancelled. Now it is a cubic equation, so take every term to RHS side, that is y cube plus 3y square minus 3y minus 5 equals to 0. Okay, so by solving this cubic equation we are going to get the solution. Okay, so that is, we have to find the possible values of y. Okay, what is y? Sin x plus cos x. So sin x plus cos x, maximum value is root 2, minimum value is minus root 2. Okay, so y compulsory between plus root 2 to minus root 2 to plus root 2. Okay, that you have to check first. Right, so I am substituting y equals to minus 1. Right? Keep y equals to minus 1, whether it is satisfying or not, that is minus 1 plus 3 plus 3, so 6 minus 1 5, 5 minus 5 0. Okay, so one of the factor is y plus 1. Okay, so y plus 1 is okay, and we don't know about the other two factors, so that is why I am using harness method. Okay, so here minus 1, so this is 0, 1, minus 1, 2, so this is minus 2, and minus 5, so that is plus 5, which is equals to 0. So y plus 1 into y square plus 2y minus 5 equals to 0. Okay, but if you observe, this discriminant is less than 0, means roots are imaginary. So sin x plus cos x cannot be imaginary, so only possibility is sin x plus cos x is equals to minus 1. Okay, that is, I am dividing the whole equation with root 2, that is cos x root 2 I am dividing, so cos pi by 4 plus sin x into sin pi by 4, which is equals to minus 1 by root 2, as we divided with root 2, so that is cos of x minus pi by 4 is equals to minus 1 by root 2. So when you are writing cos theta equals to cos alpha, alpha must be in closed 0 comma pi closed, so that is why this is cos 3 pi by 4. Okay, so now it is of the form cos theta equals to cos alpha. So cos theta equals to cos alpha means theta is equals to 2n pi plus or minus alpha. Okay, where n belongs to z, and we have to calculate x value, that is x is equals to 2n pi plus or minus 3 pi by 4 and minus pi by 4, that will be plus pi by 4, comma n belongs to z. Okay, this is the required solution, very important model. Let's say second problem, it's a different one. 3 root 3 sin cube x plus cos cube x plus 3 root 3 sin x into cos x equals to 1. Okay, so see here, 3 root 3 sin cube x is given, so that 3 root 3 sin cube x can be written like root 3 sin x whole cube plus cos x whole cube. Okay, and that plus 1 I am taking to LHS side, that is minus 1, and plus 3 root 3 sin x cos x I am writing like this, minus 3 root 3 sin x into cos x into minus 1. So minus minus it will be plus, there is no change. So it is like a cube plus b cube plus c cube minus 3abc equals to 0. So when it is possible that when a plus b plus c is 0, that is root 3 sin x plus cos x should be equals to 1. So to get the general solution, I am dividing with root 2. Sorry, I am dividing with 2. Okay, that is 1 by 2. Okay, root 3 by 2. So root 3 by 2 is nothing but sin 60 I can write. So I am writing that sin x into sin pi by 3 plus cos x into cos pi by 3. So cos a cos b plus sin a sin b, which is cos of a minus b, and this is cos 60 degrees. So cos theta equals to cos alpha. So general solution is 2n pi plus or minus alpha pi by 3. So what is x value? X is equals to 2n pi plus or minus pi by 3 plus pi by 3, and where n is belongs to capital Z, integer. Different model, but you have to get this idea. When a plus b plus c is 0, a cube plus b cube plus c cube minus 3abc will be 0. Okay. Next question. Cosec x minus cosec 2x is equals to cosec 4x. So we have to find general values of x. So to solve these kind of problems, we have to convert into sine first. Okay. So what I am doing is 1 by sine x. I am sending this LHS part to that side, which is 1 by sine 4x plus 1 by sine 2x. Okay, so that is 1 by sin x is equals to sin 4x plus sin 2x by sin 4x into sin 2x. Okay, so here numerator is sin c plus sin d, numerator is sin c plus sin d. So what is the formula? 2 sin c plus d by 2, so that is 2 sin 3x, cos c minus d by 2, so that is cos x, by sin 4x into sin 2x. So now I am taking cross multiplication, so that is sin 4x sin 2x equals to 2 cos x already there, so we are multiplying with sin x, which is nothing but sin 2x. Okay, and this is very important, like both the sides sin 2x is there, we should not cancel it, we have to take those two terms as common. Okay, if you cancel it you will lose one solution. So sin 2x into sin 4x minus sin 3x equals to 0. So this is sin 2x into, and sin c minus sin d, that is 2 cos c plus d by 2, that is 7x by 2. Okay, sin c minus d by 2, so that is sin x by 2 equals to 0. Right, now any one of them can be 0, so when sin is 0, what is the solution? 2x equals to n pi, so that is x is equals to n pi by 2. Similarly, when cos will be 0, at odd multiple of pi by 2, so 7x by 2 is equals to 2n plus 1 into pi by 2. So x is equals to 2n plus 1 into pi by 7, and sin x by 2 0, so x by 2 should be equals to n pi, that is x is equals to 2n pi. So these are the required solutions where n is belongs to integer. Okay, so let's see another kind of problem which will deal with boundedness of trigonometric functions. So 12 sin x plus 5 cos x is LHS side, and right side there is a quadratic equation. Okay, so we have to find the x comma y values if possible. So here this is of the form a cos x plus b sin x. Maximum value is, minimum value is minus root over a square plus b square, and maximum is root over a square plus b square. So from here a is 12, b is 5, so this is 144 plus 29, root 169. So minimum is minus 13, maximum is 13. Now check the RHS part. RHS side quadratic equation is given. A quadratic equation can have maxima or minima. See, y square coefficient is positive, so it will have minimum value. It will have minimum value. So just I am using f of y is equals to 2y square minus 8y plus 21. What is f dash of y? So 4y minus 8. So we have to find critical points, that implies y equals to 2. Okay, so as y square coefficient is positive, it will have minimum value. So minimum is what? F of 2. What is f of 2? So 2 square 4 into 2, 8. 8 minus 16, which is minus 8 plus 21. So minimum value is equals to 13. So quadratic equation minimum value is plus 13, and a cos x plus b sin x for maximum value is 13. So solution is possible only at 13. That means what is the value of x, what is the value of y? Y value is clear, y value is 2, and when we will get x, okay, so this side when we will get 13. Okay, that you have to check. Okay, let's see that. 12 sin x plus 5 cos x. 12 sin x plus 5 cos x should be equals to 13. So if you take tan x like this, 12, and this is 5, then 13. Okay, then keep sin x value, that is 12 by 13, and cos x value 5 by 13. Okay, so 144 plus 25, 169 by 13, which is equals to 13. So what is the value of x? Okay, x, tan x we are keeping this one, so x you have to write it as tan inverse of 12 by 5. Okay, so these are the values of x comma y. It is dependent on the boundedness of the trigonometric functions. Next one, last problem. This is another model, inequality. Sin x greater than 1 by 2. Okay, so first of all you have to draw the graph of sin x. Okay, I am drawing that. So just consider this part, 0 to 2 pi I am doing. Okay, so 0 to 2 pi is done. Now y equals to sin x graph I draw. Now I am taking y equals to 1 by 2 line. Y equals to 1 by 2 line will be like this, which is parallel to x axis. Okay, when sin is becoming 1 by 2, one is at pi by 3, sorry, at pi by 6, and another one is at 5 pi by 6. Okay, so this value, this is at pi by 6 and this is at 5 pi by 6. Now this complete region satisfying this inequality. Observe. So whatever the value you are taking between pi by 6 to 5 pi by 6 will be more than 1 by 2. And again when it will be repeated? After 2 pi, right? Then after 4 pi. So as you know, sin x periodicity is 2 pi. It will be repeating for every 2 pi units. So sin x greater than 1 by 2 means x belongs to open pi by 6 comma 5 pi by 6. Okay, but if you have to write general solution, you have to include its periodicity. As periodicity is 2 pi, that is 2n pi plus pi by 6 comma 2n pi plus 5 pi by 6. Okay, so this is the required solution, and these kind of problems will be asked from trigonometric equations. Okay, yeah, thank you. Please like, share and subscribe.